And welcome to Code Disclosed. In this video, I will go through the two main line equations, the slope-intercept and the standard form, explaining how to go from one equation to another, and at the end of the video, I will show you how to code this using MATLAB. Alright, let's start then. First of all, let's explain a line equation in general, the slope-intercept. Suppose you have this line, L, in a Cartesian coordinates, x and y. Suppose you have two points that this line go through. The first one has a coordinates of x1, y1. The second one has coordinates of x2, y2. The first variable we need to calculate here is m, which is the slope. The slope is y2 minus y1 over x2 minus x1. Now, the second parameter here that is important for any line is the intercept. The intercept is the line that, or the point that this line crosses on the y-axis. So for example, in this case, we have this magenta line that has coordinates of 0 on the x-axis and c on the y-axis. In this case, we can formulate the slope-intercept line equation as this. L, which is the line, equals to y equals mx plus c. M here is the slope as we have seen here, and c is the intercept. Now, there is another line equation that is also that this line can represent, which is ax plus by plus c equals 0. We call this line equation standard line equation. Now, the question here is how to go from the slope-intercept to the standard line equation and the other way around. That's what we are going to explain now. Alright, so let's start. So this is our line, and this is the slope, and this is the intercept, and we are going to start with the slope-intercept line equation and see where the calculation leads us. Alright, so first of all, we can write y equals mx plus c as this form. What we have done here is that we wrote m as a fraction, n1 over d1, so we have a numerator 1 and denominator 1. And we have written the intercept as also a fraction, n2 over d2. Alright. Now we can solve this, so we can try to make here the right hand side has a denominator of d1, d2, and y here also we want to have it as d1, d2 on the denominator, so we need to multiply d1, d2 with y. So we will have something like this. So d1, d2 times y equals to n times d2 on x, and also we have the other way, the second term, n2 d1. In this case, the right hand side will have a denominator of d1, d2, and the left hand side will have exactly the same denominator, so we can cancel them because it's common factor. Alright, so let's get the y on the other side. So we have x and we have the constant here. We can get the y on the other side, so we will end up with equals 0 on the right hand side. What if we call the coefficients of x as a, and we call the coefficients of y as b, and the constants here we call it c? Let's drop the y, let's put the x and y in front of these coefficients, and we will see that we have something very similar to the standard line equation. Actually, it is the line equation. So we have ax plus by plus c. You can see here that a, b, and c are just the numerators and the denominators that we already define our slope and the intercept. Alright. The question here is how to code this, how to go from the slope-intercept into the standard line. Let's go to MATLAB to find out. Alright, so this is MATLAB. Always we need to start with clear all to clear all previously assigned variables. close all previously opened figures and plots, and CLC to clear everything you have here in the command window to declutter your code window. Alright, so let's first start with defining the x-axis vector. So x here is the line space of the line space between -10 to 10, and I will take 100 points. Alright, so now I will, so it's line space here. Okay, let's now start with the slope-intercept form. For this, I will define 2 points the line goes through. I will try to, okay, so R1 is the first point. R1, let's say it has an x equals 1 and a y equals 2. R2, let's say has an x equals -1 and a y equals 0. Alright, so these are 2 points. Let's calculate the slope here. Calculate the slope, and we have seen that the slope is the difference between the y's of these 2 points, so R2 2 minus R1 2 over R2 1 minus R1 1. Okay, so this is the slope. We have the intercept now, so calculate the intercept, or the y-intercept. Now we know that we have y equals mx plus c. This means that c here can be written as y minus mx. So if I take the y and x of either of these points, and I already have m, which is the slope, I can calculate c, which is the intercept. So I can say here the intercept equals to, let's take the first point here. So the y of the first point, so R1 2, minus the slope times the x of the first point. So now we have the slope. Okay, so what is the slope-intercept form in this case? I will call it y1. This is my line. This is the slope times x, and plus I have the intercept. All right, so let's plot it. Let's visualize it and see how it looks like. So let's construct a figure, and let's plot my x and the line in a blue line now, and the line width that I want here is 1.5. I need to define the x label, which is x in our case, and I want to define the y label, which is y in my case here. Okay, so let's run this and see what we will have, what kind of line we have, and let's see the slope and the intercept of this line. All right, so let's see. It's still running. Oh, so yeah, all right, so here we have the y label, y. Okay, so let's call here y label, and let's run it again. All right, so this is our line, and it has a slope. Let's see what the slope equals to. So it's equals to 1, and we have the intercept here. Let's see what the intercept is. So the intercept here is also 1. So it crosses the y axis at 1. Okay, cool. Now so this is the slope intercept form, and we want now to go to the standard form. Convert to standard form. Now we have seen before in the slides that if we convert the slope and the intercept, that we have here from numbers to fractions, we can do some kind of manipulation to the, or some kind of very simple calculations to the equation we have, so we can end up with the standard form. One way to do this, in MATLAB, we have something called the rat command. So if I say n1, d1, so this is the numerator, the first numerator, first denominator, and I want to use the rat for the slope. So this command here converts the number, which is the slope that represents the slope, into a fraction that has numerator and denominator. All right, now I'll do exactly the same thing. So n2 d2 equals to rat of intercept. Okay, so so now we have the n1 d1, n2 d2. We know what A, B, and C of the standard form looks like. So here we have, let's say, y2 equals ax plus by plus c equals 0. I want to get to this one. And I know now the relationship between A, B, and C with the n1, d1, n2, d2. All right, let's define them. So we have seen that A is n1 times d2. And we have seen that B is minus d1 times d2. And we have seen that C equals to n2 times d1. Okay, now let's define the standard form now. So I know that y2 equals to ax plus by plus c equals 0. I think I can write this as y2, so this is the standard form, ax plus by plus c. So y2 here, I can say that it's minus over b, so it's a minus a x minus c. I just evaluate y from this equation. Okay, so here I can say y2 equals minus over b, so minus a times x, a times x minus c. Or here we have plus c because the minus, I put it outside, and this is plus. Okay, now I think I have y2. Let's plot it. Let's visualize it. See how it looks like. So let's put here hold on. Let's add hold on to the first figure that we have here, because I want to see y2 on top of y1 to see if they match or not. So here we have plot, and I want to plot x, and I want to plot y2. Let's plot them in green x's here. Okay, let's run this and see if they match. Ooh, okay, so you can see here, let's make it bigger. So the blue line is the slope-intercept, and these green x's is the standard form. Okay, maybe we need to add a legend here because it will make things, so this is the slope-intercept, and this is the standard line. Let's add this. Let's add the legend here. Okay, so, all right, okay, good. So here we go. One last step, I want to calculate the error between both forms. It's just to confirm that these two forms are actually equivalent or the same. We can calculate the mean error. So the mean error here is the mean of the absolute value of y1 minus y2. And by the way, so this is the mean error or the mean absolute error. We can also calculate the MSC, or the mean square error. We can write it as the mean of y1 minus y2, and then I can say time or squared. That is the mean square error. Okay, let's see how this looks like. Let's calculate these two errors, and hopefully they equal to 0, because this would confirm that these two forms are exactly the same. So this is the first one, it's 0, so the mean absolute error is 0. What about the MSC? Is also 0. This confirms that the standard form and the intercept slope-intercept form that we have coded here, they are both equivalent. All right, so that's it for now. Thank you very much. I will include, you can find the code here in the GitHub link below in the description. If you have another way to code this, please let me know in the comment section. Thank you very much, and I'll see you in the next video.